Determine for the following sinusoidal functions the amplitude, the period, and the max and min. Okay, so we've seen that we don't actually need a drawing to do this. We can read those numbers right out of the function if we know what we're doing. This number is the amplitude. So these functions have amplitudes of 0.5. This one's amplitude is 6, and this one's amplitude is 2. Ignore the negative if there is one. The amplitude is just the magnitude of the number out front. It doesn't matter what its sign is. The sign determines the phase of the wave, which we'll get into much later. So amplitude's pretty easy. Period is a little more work because it's not just a number that you read off. You actually have to do something with it. The period for a wave is 2 pi divided by b. By b I mean this multiplier right here. So, for 0.5 sine 3x, the period is 2 pi divided by 3. And they say they want this to 2 decimal places as well, so, okay. 2 pi divided by 3 is 2.09 radians. This one also has a 3 in front of the x, so its period is also going to be 2 pi by 3, or 2.09 radians. And here we get something different. The period for this last one, period, is 2 pi divided by 0.25. Again, if there's a negative, ignore it. That just tells us whether the function is phase reversed, which we'll talk about much later. For this, I just need the size of that number, 0.25. 2 pi divided by 0.25 is 8 pi. And to 2 decimal places, that's going to be 25 something. 25.13. Now, last thing, they want the maximum and minimum values. Well, those are easy because we have the amplitude. An amplitude of 0.5 for a sine function means it's centered around 0, it has hills that are 0.5 of a unit high, and it has valleys that are 0.5 of a unit deep. So for this one, the max will be 0.5, and the minimum will be minus 0.5. It goes half a unit up, half a unit down. This one's amplitude is 6, so its maximum will be 6, its minimum will be negative 6. And this one has an amplitude of 2, so its maximum will be 2, and its minimum will be negative 2.